Everyone, so we are coming to you from the Donahue household where we are having our digital snow day. I will be giving you notes via video here, and I ask that you take notes. So whether or not you write that on your notebook, or if you could just do that by printing the blank notes off the internet, then you could fill them in. So these are the notes for today that I want to be doing. I'll talk through them. You can pause the video as needed. And then afterwards, you'll complete a quiz on Schoology that will allow you to show me that you actually watched the video and were able to complete some problems based off of what I gave you. So hopefully this turns out okay. It's our first shot at it. So I ask that you guys kind of follow along and do your best here. And feel free to email me with any questions you have. I'll be available via email. So I'm going to start with doing our warm-up problems here. So I multiply the coefficients, and then I add the exponents. So that was a review problem from previous sections. Then we have our problems where we look to see where are there more A's. Well, there are more on the bottom. There's 2 more. And then the B's, there's 3 more on top. And then finally on example 3 here, or warm-up number 3, I can simplify the 2 over -4. Remember, just treat that like a normal fraction. So that'd be a -1/2. I can put the negative on the top or the bottom or in the middle. And then I look and there's more x's on the bottom, so it's x squared on the bottom. So hopefully that works for you guys and that makes sense. That's what we learned about last class. So today we're going to talk about negative and 0 exponents, and that's a little bit of a confusing concept. So if you put in your calculator, switch pens out here, if you put that in your calculator and try to see what your calculator tells you about a 0 exponent, so if you try like 7 to the 0 power in your calculator will say 1. And that's kind of strange. So then try another number. Try like 25 to the 0 power. Your calculator is also going to say 1. So it doesn't matter what power I'm taking or what base I'm using. If I have a 0 exponent, it's always going to equal 1. So any value to the 0 power equals 1. So any value to the 0 power equals 1. And I'm going to try to explain a little bit as to why that is in a second here. So where that comes from is when we talk about dividing fractions here, we would subtract the exponents. So 5 minus 5 would be 0. Now before this, you might not have known what that was going to equal, but if I think about that as 5 A's on top and 5 A's on the bottom, they're all going to cancel. And remember, when I have a fraction with the same thing on the top and the bottom, they cancel to equal 1. So A to the 0 power will also equal 1. So any value, whether or not it be a whole number or a variable, it's always going to equal 1. So this one is a little bit different because we have 5 times x to the 0 power. So the x to the 0 part of it is going to equal 1. Any value to the 0 power equals 1. But 5, it's like it has a 1 as an exponent. So this really becomes like 5 times 1, which would just be 5. So just understanding that just that piece, the value with the 0 power is going to equal 1. So again, just a reminder, guys, if you need to stop the video or pause the video at any point, feel free to. I'm just going to keep going. So if I feel like I'm going fast, feel free to pause as you go here. So again, any value to the 0 power is going to equal 1. All of these values get the 0 power. So I could distribute that in if I wanted to, or I could just see they all have a 0 power. I'll write it out with the 2 times 0 be 0. But all of these are just going to equal 1. So kind of ridiculous to even write them. Don't need to. So I'm multiplying 1 3 times by this. Well, it's just going to equal negative 2xy. Because times 1 isn't necessary to write. So that 0 power is kind of strange. It's like I can cancel all that out. So anytime I see a 0 power, I actually think about it just canceling to equal 1. So 6 to the 0 equals 1. It's 1 times n to the second. Well, I don't need to write that. So I'm going to distribute that in. So I get n to the 6th on top of n to the 6th. Now I have the same thing on the top and bottom. So back like over here, they all cancel, or I can subtract them and get 0, which I realize just will equal 1. Everything will cancel. And again, feel free to email me with questions if you're wondering why did she just do that or what happened there. I don't understand what was happening. Feel free to send me a message if that's confusing, or you can always bring messages to class. I'm not going to expect you to come as masters at this lesson, given that I wasn't here to teach or we weren't together to learn it. So let's move along. So this little chart here, or this little list, hopefully you realize that 2 to the 4th power is 2 times 2 times 2 times 2, which is 16. 2 to the 3rd is 2 times 2 times 2, which is 8. 2 to the 2nd. So what I want you guys to notice is a lot of you guys like patterns, or you might notice patterns. And what I want you to see is that there's a pattern here. As these exponents go down by 1, these numbers change. And each time we go down the list, we're dividing it by 2. We're taking a 2 out of there. So 4 divided by 2 would be 2. So that's how I get my next value. So this kind of reiterates the fact that 2 to the 0 power should just be 1, because 2 divided by 2 is just 1. Now we're also going to get into negative exponents. And negative exponents are going to kind of make sense, I think, using this pattern. So if I divide 1 by 2, 1 divided by 2 is 0.5, or 1/2. Sorry, I'm writing kind of big there. 1/2 divided by 2 would be 1/4. 1/4 divided by 2, break a fourth in half, that's 1/8. So what's happening is as I go with negative exponents, they become fractions, and they become smaller and smaller fractions. And if you notice, this is like 1 over 2 to the 1st, 1 over 2 to the 2nd, and 1 over 2 to the 3rd. So that's going to keep happening. Sorry, dog hair. That's going to keep happening as we go down the list. So negative 4 would be 1 over 2 to the 4th. So there's a pattern there that's continuing, and we're going to use that on the back side of our notes to talk about what happens with negative exponents. So this is kind of the why behind it. Now as a student, I don't know if I ever knew the why behind it, so just be aware that you'll get by even if you just memorize the rule, but I kind of thought some of you might be interested in why this rule exists. So I'm going to flip my notes over and head over to negative exponents here. So again, hopefully you guys can write these notes down and pause as you go, or you can fill in the note packet if you printed it. So what a negative exponent does is this 1 over 8 to the negative 2, or x to the negative 4, what we're going to learn is this is currently on the top of the fraction, whereas this one's on the bottom. What we're going to do to change that exponent, we're going to move its position in the fraction. So this one's on the bottom, so it's going to be a to the 2nd on top of the fraction, or just a to the 2nd. The x to the negative 4 is currently on the top of the fraction, so we're going to move it to the bottom, and it becomes positive. So well, we're going to write this down as negative exponents. You move bases with negative exponents. And I'll write here, switch position in the fraction. So if it was on the bottom, it moves to the top. If it was on the top, it moves to the bottom. But you only move bases that have negative exponents. So looking at these, I'm just moving the bases with negative exponents. So both of them have negative exponents. They're going to switch and they become positive. Oops, that should be an n. Sorry. It's an n to the 4th. Now, careful, negative numbers are fine. Negative numbers, this -2 has a positive 1 as its exponent, so it can stay where it is. So do not move negative coefficients. So that just stays where it is because it's a negative number, not a negative exponent. So it stays where it is. So this next one here, I have -2/4. Just like we did on the front side, we're just going to simplify that. So -2/4 is a -1/2. But now I only move bases that have negative exponents. So this x is like an x to the 1st, so that can stay where it is. X is fine. But the w's aren't. The w and the y isn't. So I'm going to move, I'm going to move that. Move it to the top. And the y is going to move down. All right, so those switch positions because they both have negative exponents. And then that's considered done. All right. All right, so looking at this next one, we have only some negative exponents. So a to the 3rd is fine. The b's and d's both have negative exponents, so I need to switch their position. Whoops, I keep doing that, sorry. So d to the 4th is going to move up, and b to the 2nd is going to move down. So they're going to switch positions. But then the c and e don't have exponents. They really have an exponent of a 1, so they don't need to move. So we leave them like that. All right, next one here. I can simplify -12/4. So this is a -3 on top, a 1 on the bottom. Now with these negative exponents, I'm going to switch them around. So the negative exponents are going to flip. So a to the 2nd, a to the 3rd, because they were both negative. You can see that. But then the b's, I might use a different color with the b's here. So this one is negative. So that one's going to move up. But the b to the 4th is positive, so it's going to stay where it is. So this one moved up to the top because it was negative. And then the c's, there's more on the bottom than the top. There's 4 more. Now I'm not quite done. I can simplify a little bit more. I don't need the 1, but I'm just writing it so you know that it's okay to put it there if you want to. A to the 2nd over a to the 3rd, it's just a to the 1st on the bottom. The b's, there's going to be 7 on top. And then the c is going to be the 4th power on the bottom. All right, so then that's simplified. This next one, we're looking at this, again, the coefficients. I'm just multiplying. So 5 times -2 is a -10. Now, I don't know how comfortable you guys are with adding exponents. It's up to you guys how you want to do it. Since this, so this one's kind of trying to decide what you guys want to do here, but we have a to the 3rd and a to the -7. If I add those exponents, 3 and -7 is a -4. We'll do something with that in a second. Then y to the -2, y to the 6. So just kind of making sure you guys understand where that came from. Back here I had 3 plus a -7 is how I got -4. And then I have -2 plus 6, so I have y to the 4th. And then I just have z and z, so z squared. But I'm not quite done yet. I can't leave it this way because of this negative exponent. So I'm going to make a fraction. So everything that has positive exponents stays on top, but the negative exponent is going to move to the bottom. All right, a few more examples here. So suggested steps for simplifying. Now notice it says suggested. So that means you might use other methods or you might do different steps and it'll still work. I'm not saying this is the only way to do these problems. So on our problem here, I like the idea that I could probably simplify what's inside first before I distribute that power in. So simplify inside parentheses first. So simplify inside the parentheses. So if you guys look, I have this x to the negative 3. I'm going to move that to the bottom. This y to the negative 1 I'm going to move to the top. And then that z to the 0, don't forget those 0 exponents, I'm just going to get rid of that. So I'm going to have 5 on top. This is going to be on the bottom. This is going to be on top. And the z's gone. Okay, I'm going to go another step here. So this is y to the 5th. And x to the 5th on the bottom. All to the 2nd power. So I simplified the parentheses first. Now I'm going to distribute that power in. So I'm going to distribute this power into all the places that we're able to put that in. So 5 to the 2nd, y to the 10th, because you remember you multiply power to a power, and x to the 10th. And all I have left to do is 5 to the 2nd is 25. All right, sorry, stay there for a second. And so then that everything's positive, it's good to go. Now you do want to see if you can simplify further. So always check and see, can I simplify again? So like, am I done? Can I simplify anymore? I should try to if I can. So this next problem, and again, this is just suggested steps for simplifying. You might not choose to use the method I use, but so if I can simplify what's inside the parentheses first, I might. Now this one, I don't know how much simplifying you would do. Maybe move this y to the 2nd to the bottom, but let's just wait. I'll show you guys that you can use other methods here too. So I'm going to do negative 3 to the 3rd, x to the 3rd, and y to the negative 6th. Now don't forget, negative numbers are okay. We just don't want negative exponents. But then this is going to drop to the bottom. And so negative numbers, okay, negative 3 to the 3rd is a negative 3 times negative 3 times negative 3, which is a negative 27. Now this, everything is being raised to the 0 power, so what happens? It all cancels to just be 1. Now you could distribute that in. They'd all just become 1 over 1. We don't need to do all that. And then finally, this last one, again, I'm going to move this g up to the top, move this h to the bottom, my timer is going off for my dinner, so sorry for the beeping. Alright, so all I did was move that h to the bottom. The g's I can simplify, I can put them together. Sorry, this is going to be a longer problem. Okay, now I'm going to distribute that power in. So 2 to the 2nd, hopefully you guys realize that's just 4. Okay. Now I can cancel the 4s. Now there's 6 g's on top, 1 on the bottom, so that'll be a g to the 5th on top. I'm running out of space here. And then in h, there's 3 on top, 4 on the bottom, so h to the 1st on the bottom. So then that'll be our final answer. Oh man, you guys, look at, I lost the 3 way back when. So there should be a 3 that keeps moving around along with us, sorry. So that 3 would just be on the bottom then, sorry. I'm not redoing the whole video for that one mistake. All right, so homework is listed here. Try your best on it, see how it goes. This second section is review problems, so maybe that might be better to start with. This one's the new ones that we're doing. But there are going to be like 3 questions on Schoology, 3 or 4 questions about our notes. So hopefully you took good notes and it makes sense. Otherwise, again, feel free to shoot me an email if you're having any issues. Hopefully we'll see you soon this week. Otherwise, stay warm and have a good snow day and cold days if necessary. Take care. Bye-bye.